Thanks. So, good morning, everyone. Thanks for coming up. Thanks for tuning in. I would like to introduce ourselves a bit more with our case of unsupervised machine learning for scale visual inspection. First of all, Covision Quality is a spin-off out of our company builder Covision Lab. We are based out of the south of Italy, also of South Tyrol in this case, so north of Italy, of course. And we're backed out of 7 multinational companies, and Covision Quality is a spin-off. So, and with Covision Quality, we automate and scale visual inspection. The team behind Covision Quality, we're around about 20 people at the moment. Most of them are on this slide. We cover them, or we catch them out of the best universities out of Europe and overseas, and out of the especially product holder companies all over the world. But why do we also decided to go to this big field of computer vision and visual inspection? Because we still see this at the moment. We have a lot of computer vision, visual inspection machines in the field, but we have always 3 key points. The first, vision systems are difficult to program. Rule-based vision systems, but also other vision systems. The personnel who can code or program or to scale are rare and quite costly. And the third point, and this is the most important point in our case, is the outcome is often very unspecific. And that's why we decided to do our own visual inspection system with a new approach. And every project from us started with 1 picture. But not 1 picture, we're always starting with a couple of pictures. We're not learning on defects, we're learning out of more than 100 or more pictures. So we are focusing the unsupervised way. That means we don't need to label images. We are learning from patterns all over the field. We believe that unsupervised machine learning can be a big approach in the future because to the fact that we can find defects who've never been there before in the way that you can see what happens also when you're not knowing what is happening. And we all know when we start a project, anything about any defect, don't know. So our approach is that unsupervised is quick and we can get it within 1 and 2 hours without any coding and without any specialized program. But how we do this? We have 4 key points here. We're using the unsupervised machine learning from the patterns, what I said, but we are matching this with a CAD file model to build the ground structure for our whole system. At the end, we can use various hardware. We bootstrapped our software on ourselves, so we can use 2D, 3D, and volumetric data. All this kind of volumetric data, we see a big approach in the future because of volumetric data getting quicker, more density, and cheaper, of course. And we introduced something new last week. It's called the one-click training from us, so a very user-friendly process to set up a vision system without any experts behind. So we have here a monitor, what is inline. You see here it's quite a very simple monitor for the operator inline, not to interact too much with him. He has here the opportunity to send out some images to the supervisor that he has also an overview about. But the second thing is we have a management panel. And the management panel, we are quite proud of that because we see here more lines over different fields with all the management things you have to know, production speed, scrap rates, etc. Out of this team, you can make your whole quality system. You can bring out the PowerPoint, the Excel, the CVC files, all of this, what you need to report to your supervisor, etc. our three USPs on the software side is using unsupervised machine learning, transfer learning for not every time setting up a new system that we can transfer to a new part on a quick way without knowing every time the future, and of course the continuous learning for the approach that we can push ourselves every time a bit faster. But now, for the rest of the time, I would like to talk about some applications, what we are solved, because at the end, we all know it's only a presentation, but how is it working in real life? For this, we have a look to the high-volume parts on a 2D camera system, and on the other hand side, on our 3D pipeline, the volume parts on 3D data. So, on this side, you can see the challenges. We have every 220 milliseconds a new part. We have stereo surface changes several times a day, like you see on the 4th of April this year, and then to the 13th of April. So we are changing light situation, we are changing surface situation. This is the powder metal part. So powder metal is every time a bit different from the surface. And we have every time new unspecific errors because of they produce this in several machines. What we did here. We got the annotating CAD file from our customer where they selected the most important areas, like you see on the right-hand side of your view. So green is OK, red is very critical, and the yellow one is the middle. So we also have here the opportunity to select defects for the future. And having here the one-click training that we're learning from the patterns and can go inline within 1 or 2 hours. And then, of course, the job has to be done with the MSA test, etc. But it's like always. On the other hand side, we have a 3D application where we are quite proud of that, because this is everything is bootstrapped on ourselves on the software side. We have here a 3D application on the die casting process. Die casting with every time changing surfaces and everything. So the cycle time is 5 seconds. We have a 2D matrix camera from above and 2 laser triangulation sensors in the middle, and the part is turning. Produced it will be with a robot. In this, we are catching the file with 2 laser triangulation sensors and match these always with the CAD file. So we see the difference between the CAD file and the file what is really before. And then at the end, we make our unsupervised approach and see the defects like this were on the right-hand side. One of our clients, or 3 of our clients, what we can public selected here is, for example, GKN, the biggest powder metallurgy company in the world, where we are within a couple of lines with them. And they seem to be happy with our solution here. That is the head of adaptive technologies, Thomas. And yeah, for the future, to having an outlook, what comes up. Of course, we want to expand on the horizontal in manufacturing. We started with metal, continued with plastic, and we are now between packaging and boards. And for the future, we see also a vertical expansion. So more from the visual aspect, like we saw on the management panel. Every data what we can grab out of visual inspection, of defects, of scratches, of burr holes, etc. We see this, this is also important for shift analysis, runtime prediction, and all of this production maintenance. And this is our approach for the future. Thanks.
Thank you, Markus. Questions from the jury? Here, I see one. Please, Sigrid.
What's your business model? Is it only the software, or do you integrate?
At the moment, we are also integrating because of the fact that we are a small startup. At the end, we want to come more and more as a software model. Yeah.
Mark?
You said it's a software as a service. Is it in the cloud or is it locally processed for speed? Or
it's local processed for the speed. All of these facts that we see a couple of security issues when we talk with our clients in the industrial field, they are not willing to give their data to the cloud at the moment. If there will be a shift in the future, we can go to the cloud as well.
Okay, so one of the other challenges I see in a general machine vision system, it's not the actual software that does the detection, it's the interfacing to the factory, interfacing to the PLCs to do the rejects.
Exactly.
Does your software, is it a one-stand software? Do you have to integrate it into a wider automation system? Does it? Yeah. What interfaces does it have?
It depends on, we are white labeling our software that our customer can integrate it in their whole system, or our system is a standalone. We are coming always with a standalone computer for the runtime, etc. And this can be absolutely integrated in every PLC like ours, because we have the entrance to Profibus, etc., Profinet, EtherCAT, and all these. What is important here.
So, thank you.
Thanks.
I can't allow any more questions, I'm sorry. We have to move to the next speaker.